sigma notation. It sounds intimidating, but there's absolutely nothing there. So as I said, we managed to find the sum of the first three terms manually. We used the formula, so now we're using sigma notation. Okay. Now, how do we do this? Ne? Sigma notation always comes like this. Loosely speaking, it comes like this. Ne? Where sigma means we're adding, then this means like the nth term of whatever series you're dealing with. I'm not sure we have the arithmetic series and the geometric series, but in this context, we're dealing with a geometric series. So in place of Tn, you're going to put the general term of the sequence. What am I saying here? So let's rewrite the series in question. It is 2 plus 6 plus 18 plus 54 and so on, right? So now by Tn, they just basically mean this, the Tn, the normal Tn of a geometric series, which is this. That's what it is. We did this last week. The same way the general term of an arithmetic sequence is this. So this is the general term of a geometric sequence. Now, that's what you're going to put here. Now, let us find the Tn for this specific sequence or series. Tn equal to, this represents the first term, while the r represents the constant ratio, the number you multiply to get the next term. And then we have something like this. And I emphasize that please do not multiply these two, because when you multiply it, you're going to get 6n to the power minus 1. And then this n minus this exponent n minus 1 does not affect the 2. So by multiplying these two and getting a 6, you're saying that this affects the 2 as well. So that is a criminal offense. Don't do that. But please watch the videos to get more clarity on what I'm saying now. So this is the general term of the specific series or sequence, whatever. So this is what we're going to put there on sigma notation. That's about that. Now, remember that we found S3 manually and using the formula. So for us to find S3 using sigma notation, we're going to do this. So finding S3, put 3 there at the top. Then n equal to 1, sorry. So what does this thing mean? I'm going to write this thing. This is a math statement, right? But I'm going to write it in English. It means find the sum of the first 3 terms of the of a sequence with general term Tn equal to 2.3 to the power n minus 1. That's what it is. Or you're just adding the first 3 terms. So when yeah, so that's about that. So what you would do in an exam, you could do this. Yeah, so that's about that. You guys understand the statement before I get into it? You guys understand the statement that this means that? Okay. Let's talk. Yeah, the whole thing. Yes, the whole thing. So this whole thing, which are you start. I'm gonna show we're looking for the first 3 terms, right? So what you're gonna do this. You're gonna go. You're gonna substitute into this Tn. 2.3 to the power n minus 1, right? You're gonna substitute wherever as n you put 1. That's you looking for the first term. I get writing down the first term, and then plus the second term. Remember that this is a general term of the sequence. 2.3 2 minus 1. You substitute 2 now then, plus. That's what sigma means. Sigma means plus. You're summing. 2.3 3 minus 1. So you end where? At 3. So you see, you're finding the sum of the first 3 terms. If you calculate this, you'll get here. This thing will give you 2. This thing will give you 6. This thing will give you 18. See, So you're finding the sum of the first three terms. Lulama, can you connect this, and that? Can you please respond with a thumbs up, or like say something, just to make sure that you understand. Yes. Yeah, good question. So he's saying that if we're looking for the sum of the first four terms, that is, so you guys so far you see that this gives us S3, right? The same answer as the two methods we've already covered. You guys see that manually and formula wise. So now he's asking if we had a 4 here, would that mean we're looking for the sum of the first four terms? Absolutely. So this would then become plus 2 to 3, 4 minus 1. So yeah, that's what that would mean. All right. So now this thing, as I said, yes, n equal to 1. I'm gonna play around with the n just now. I'm gonna put 0 and all of that stuff. But just allow me to explain something quickly. I'm gonna put a 0 and everything. I'm gonna come to that. Yeah, so I was just saying all of us are happy. I'm gonna come to that, Lama. So I'm saying all of us are happy with the statement that this thing means find the sum of the first three terms of a sequence with general term that. So always just know what a sigma notation comes like this. It's a sigma, meaning you're gonna sum the individual terms, and here you've got the sequence itself, the general term of the sequence. If you're working with a geometric series, it's gonna be the Tn of a geometric sequence. If you're working with an arithmetic series, it's going to be the Tn of an arithmetic sequence. All right, that's about that. Now, a question normally would come like this. Would come something like this in exam. Maybe just say question 5, 5.1. They'll just write this. They won't say anything. They'll just write this. They'll just write evaluate. Okay, and write this. What does that mean? Right? It just means the sum of the first. It means mm, the sum. Find. It means find or calculate the sum of the first two terms of uh, of Tn equal to this sequence. It's a sequence. That's what they're looking for. Sharp. So that will obviously be 2 plus 2 there. Okay, that's about that. So that's S2 basically. So that is 2 plus 6 gives us 8. Okay, sharp. Now let us now come to situation where we have a 0. So we've got a it's a question, in exam. You've got a series. It says 2 there. It says n equal to 1, like that. Then we've got another one. Okay, the difference between these two is that the first one starts at 1, while the second one starts at 0. So let's just expand each one of them so that you guys can see the comparison. Sum of the first two terms, so starting at n equal to 1. So in place of n, we put 1. That's where it starts. Plus, that's what summation means. We move to the next one. That's about that. That's what they're looking for. Then with this one, goes like this. It's 2.3 starts at 0. So you replace the n with the 0. Then plus, that's what summation means. 2, the next number is 1. Plus summation, the next number is 2. So do you guys see the difference? So this one starts at 2 plus 6. This one is starts at 2 over 3 plus 2 plus 6. Do you guys see the series? So in a typical question, let's just say they didn't ask you this question this way, but they asked it, they presented it like how? Like this way, like they represented it this way. Like you get a series and they start off by saying this is a geometric series, blah blah blah. Then this is you having written those two series that in that manner. So it would be a series 2, this one would be series 2 plus 6 plus 18 plus 54 and so on. This one would be a series starting at 2 over 3 plus 2 plus 6 plus 18 plus 54 and so on. Do you guys see the difference between the two? Barakemang, Lulama, you happy? Yes. Thank you for that question. The 2 at the top tells you where to stop. Now, now how to find the number of terms in that specific series they're referring to using sigma notation. You do this. N, thank you for that, Bozayam. This is where to stop. Where to stop. Okay, for both of them. Then how to find the number of terms in whatever they will be referring to, this the sigma. You go top minus bottom plus 1. Always, always. So let's check if this formula works for the first series. For this one, top is 2 minus bottom is 1 plus 1. The one is always there. This gives us an answer of 2. So therefore, there are only 2 terms in this series. This specific sigma series ends there. Okay, let us see. So it makes sense because we've got 2, 1, 2. Let us see if we use the same formula, we're gonna get 1, 2, 3 members. Let's see. It's top. Our top. It's top. Our top is 2 minus. This is the minus. Bottom is 0 plus 1. 1 is always there. This gives us 3. So this tells you that we've got 3 members of members in this series. Delicious, ne?